this very lesson, we shall be looking at the part 2 of expressing recurring decimal as a common fraction. In our previous lesson, we learned how to express recurring decimals such as 0.3 dots as a common fraction. We also learned how to express recurring decimals such as 2.15 dot dot as a common fraction. We also learned how to express, let's say, 1.306 as a recurring decimal as a fraction. So we learned that the number 3 recurs or repeats infinitely. So we can write this as 0.333 up to infinity. And then 2.15, we can rewrite it as 2.151515 up to where? Infinity. Similarly, we can write this as 1.306 up to where? Infinity. So we said that all these numbers are recurring or repeating decimals. We learned how to express this as a common fraction. We realized that all the examples that we solved, all those recurring or repeating decimals were right behind the decimal point. So you can see that 3 repeats infinitely and it is just behind the decimal point. We can also see that the number 15 repeats infinitely and it is just behind the decimal point. Similarly, the number 306 repeats infinitely and it is just behind the decimal point. Now we are going to look at a situation where the number that repeats infinitely is not just behind the decimal point, but behind a certain number. So let's take it that you have 0.57 dots. This is a recurring decimal. And you can see that the number 7 repeats infinitely, but it is not right behind the decimal point, but behind a certain number. And we know that this can be written as 0.5777 up to where? Up to infinity. We can also look at a question such as, let's say, 0.83 dots, which is the same as 0.8333 up to infinity. We can also look at this 1.213 dots, which is the same as 1.2131313 up to infinity. So you can see from these few examples that the number that repeats or recurs infinitely are not directly behind the decimal point, but they are behind certain numbers. So when you have questions of this nature, how do we go about it? That is what we are going to look at today. So let's take our first example and then see how we can go about it. So we have to express this as a fraction. So we know that, so let's write our solution. We know that 0.57 dots is a recurring decimal, and the number that repeats or recurs infinitely is 7. So we have 0.5777 up to where? Infinity. So the first thing that we are going to do is to let a variable represent the decimal number given, any variable at all. So let's choose x. So we let x represent the decimal number 0.5777 up to where? Infinity. then we call it equation 1. Now you can see that the number that repeats infinitely, which is 7, does not come directly after the decimal point, but after the number 5. So you have to deal with that one first before we move on to the number that repeats infinitely. So in doing so, we can see that the number that comes just behind the decimal point is 5. It is only one digit that comes behind the decimal point. That is 5. And that 5 does not repeat. So what we are going to do is that we are going to multiply equation 1 by 10, because the number that comes directly behind the decimal point is what? 5, and it is one digit. So if it is one digit, we multiply equation 1 by 10. If it is two digits that comes just behind the decimal point and does not repeat, we multiply equation 1 by 100. If it is three digits that comes directly behind the decimal point and does not repeat or recur, we multiply equation 1 by 1000 in that order. I guess you've gotten the clue. So we have 10 times what? X. Then we have 10 times what? 0.5777 up to infinity. Then after that, we simplify. 10 times x will give us what? 10x. 10 times this will give us 5.777 up to infinity. Then we call this equation 2, because we have equation 1. This is equation 2. Then after that, we deal with the number of digits that repeats infinitely. We deal with the number that repeats infinitely. So looking at this, you can see that it is only one digit that is repeating infinitely, and that digit is what? 7. So since it is one digit that is repeating, we multiply equation 2 by 10. If it is two digits that are repeating infinitely, we multiply equation 2 by 100. If it is three digits that are repeating infinitely, we multiply equation 2 by 1000 in that order. So we have 10 times what? 10x. Then we have 10 times 5.777 up to infinity. So we have 10 times 10x to give us what? 100x. 10 times 5.77 will give us 57.777 up to infinity. We call it equation 3. I guess you are following. Let's continue from here. So the next thing we are going to do is that we are going to subtract equation 2 from equation 3. So with this, we are going to deal with equation 2 and 3. So we have, equation 3 minus equation 2. So equation 3 is this, minus equation 2, which is this. So we have 100x minus what? 10x is equal to 57.77 minus what? 5.77. 57.777 minus what? 5.777, all up to infinity. So we have 100 minus 10x will give us what? 90x. 57.77 minus 5.77. Since those numbers behind the decimal point are the same and they recur up to infinity, when you subtract them, they'll cancel themselves, or they'll give you 0. When you subtract those recurring numbers behind the decimal point, you are going to get 0. So we have 57 minus 5. 57 minus what? 5. Good. So we have 90x is equal to what? 52. We are looking for s, so we divide both sides by 90. Both sides by 90. This and that will go. So we have 2 into 52, we have what? 26, right? So we have 26, and then 2 into 90, we have 45. So you can see our x is equal to we have 26 over what? 45. Very, very easy. So you can punch 26 over 45 on the calculator, and it is going to give you 0.57777 in that order. I'm going to give you one example. You pause the video, you try your hands on it. So try this. 0.83 dot. Write this or express this as a common fraction. So we have 0.83 dots. So you know that 0.83 dots is a recurring decimal, and it is the same as 0.8333 up to infinity. So we can first let a variable, let's say x. So we let x equal to the recurring decimal. Then we call it what? Equation 1. Then after that, we look at the numbers behind the decimal point. We can see that the number that repeats infinitely does not come directly after the decimal point. There is a certain number there, and that number is what? 8. And this 8 is not repeating or recurring. And since it is only one digit which is not repeating or recurring, and that number is 8, we multiply equation 1 by 10. Good. So we have 10 times what? X is equal to 10 times what? 0.8333. Then we simplify. 10 times x will give us 10x, and 10 times this will give us 8.333 up to infinity, and then we call it equation 2. Then after that, realize that the number that repeats or recurs infinitely comes directly behind after the decimal point. So we are going to look at the number of digits that repeats. So how many digits repeats? It is only one digit that is repeating infinitely, and that digit is what? 3. So we are going to multiply equation 2 by 10 because it is only one digit that is repeating. So we have 10 times what? 10x is equal to 10 times what? 8.333. So let's simplify. 10 times 10x will give us what? 100x, and this will give us 83 point what? 333. Let's call this equation 3. So we take equation 2 and 3 and we subtract equation 2 from 3. So we have equation 3 minus equation 2. So equation 3 we have 100x minus what? 10x is equal to 83.33 minus 8.33. 83.33 minus what? 8.33. So we have 90x is equal to, since those numbers behind the decimal point are the same and they repeat infinitely, they will cancel out or they will go to 0. And then we'll be left with 83.8 will give us what? 75. So we divide both sides by 90, both sides by 90. So 90 will cancel 90. We are left with s is equal to 75 over what? over 90. So we have s is equal to 75 over 90. But I believe we can break it down, right? We can use 5. 5 into 75, 15, right? So we have 15. And then 5 into 90, we have 18. We can still break it down. So we have s is equal to 15 over 18. So we have 3 into 15, we have 5. And then 3 into 18, we have what? 6. So we have our s is equal to 5 over what? 6. Very, very easy and simple. So as I've been saying, anytime you get your final answer, you can point it to the calculator to see if you are really right or wrong. So you point 5 over 6 on the calculator, you press equal to, you press SD, and it is going to give you 0.83333 up to infinity. We take the last example, we run out of here. So we have to express 1.213 dot dot as a common fraction. So we know that this is a recurring decimal, and we can write it as 1.213 dot dot is the same as 1.2131313 up to infinity. So you can see that the number that recur or repeat infinitely are what? 1 and then 3. Good. So looking at this, we are going to let a variable, let's say x, equal to the decimal number given. So we have 1.21313 up to infinity, and then we call it what? Equation 1. Then after that, we look at the number that comes directly behind the decimal point, and that number is what? 2. Since it is only one digit that is behind the decimal point, that is not repeating or recurring, multiply equation 1 by 10. Good. So we have 10 times what? X. 10 times what? 1.21313. We simplify. 10 times x will give us what? 10x. And then 10 times 1.21313 will give us 12.1313. So we call this equation what? 2. Good. Now we also realize that behind the decimal point, certain number recur or repeats infinitely. And those numbers are what? 1 and 3. 1 and 3. So how many digits repeats infinitely? It is only 2 digits that are repeating infinitely. Because it is only 2 digits that are repeating, you multiply equation 2 by what? 100. So we have 100 times what? 10x. Then we have 100 times 12.1313. We simplify. 100 times 10x will give us what? 1000x. And then 100 times 2.1313 will give us 12. Sorry, we have 1213.13 up to infinity. We call it equation what? 3. So what we are going to do is that we are going to subtract equation 2 from what? Equation 3. Then we simplify. So equation 3 minus equation 2. This is equation 3. This is what? Equation 2. So we have 1000x minus what? 10x is equal to 1213.13 minus what? 12.1313 all round up to infinity. So 1000x minus 10x will give us what? 990x. 1213.13 minus 12.1313. Since those numbers behind the decimal point are the same, 1313, and they round up to infinity or they recur up to infinity. When you subtract them, they will give you 0. Okay, so we are left with what? 1213 minus what? 12. So we have 990 is equal to 120 what? 1. We are looking for S. We divide both sides by 990. So this and that will go. We have our X is equal to 1201 all over 990. And that is that. Very, very easy and then simple. What I'm going to do is that I'm going to give you experience set questions. You pause the video, you write them down, you try your hands on them. So these are tutorial set questions. Try your hands on them, okay? So we have 3.01201 dots dots. This is a recurring decimal, this is a recurring decimal. Pause the video, write them down, you try your hands on it. This brings us to the end of today's lesson. See you tomorrow. Bye-bye.